Okay. Now, there's two shots here. One is a lot better out in the light. See that there? That's my unit. That's what the
that's the T-piece.
That's the tube with a, what's the name on it, right? That's the whole unit. Now, this one, that's the rover. I drove down there on this, no petrol at all. We used about a cup to a cup and a half, or a cup of water to go from here down to Mount George. That's Taree out to Mount George, right? Out of that unit.
Right.
This one here.
Now what's in that unit? That's the plate system, is it?
No, that is just a mesh. Yeah, that's
yeah,
shortened down.
That's that one.
Now, when we got down there, Ron didn't accept this. He wanted to make another one, so he made this circle one, right? Now, that is very thin stainless, and the whole thing turned circular. She expanded when you revved up, and she just ballooned out. And I don't know why it didn't blow up, but that was doing polluting that motor. She had no smoke, no fumes, no nothing on anything else by petrol or by my unit. Put this one on, she done the same. She polluted. She had pressure, and that was an expanded one. We lost all brakes, we lost all manifold.
That's the circular one there.
We had no slowing down. Okay, and that's the only shot I got.
That's the T-piece, all right.
Okay.
See if I can get a close-up one.
There.
What's it off? An alpha lava, was it?
No, it was under a evacuator unit for making ice cream.
Well, they produced it. Just
That is about the unit.
It is about half.
That one.
Oops.
Centre mesh, it gets it out heaps better than the solid centre as a negative. Solid stainless outside as a positive. 2 is the best. 2 tubes, neutral tubes, outside the mesh. And what's the gap on that?
Yeah, it's approximately 6 mil.
Yeah, about 7 gap gives you the gas off.
Right.
Really well gap. You have two of those tubes, neutral tubes. They don't touch anything either end. The gas will come off both of those. Each one will drop your current in half, and you'll come down from, say, 75 amps down to 5 amps, and get off twice to 3 times the amount of gas. Is that over? This is mesh what Peter had got. Square meshing. He said he was hoping this would work. This does not work nowhere near as well because the wire, they're sealed wire, and they're just interlocked.
All right.
Right? Now the current seems to be able to go through and past. Where, if you have
welded mesh, or
if you have solid welded mesh, the current can't circulate and go past. You'll come down to the square and break out in the 4 ways and put your gas out. If you have solid tubing, first of all, you get a very, very small amount off the face, like these wires are face. The gas starts coming off the bottom really well because it is been cut and it's rough. No face, there's no shiny face. Little bit off the sides here. If you grind those sides, or you cut those sides in any way or rough it up, gas roots out there and you can see the difference between them.
right.
If you have the mesh, like this, heavier actually, is better. Where's that other one, Peter? This is the actual size.
a very large mesh.
This is cut off the mesh what we had in the units. Got that?
It's an 8 mil square, and the meterage, or the next size to the next hole is 12. So it's known as 8 mil square with 12 mil centres.
Testing this will show that off these bits here, you will get probably 4 times the amount of gas as what you can get off this stainless,
Let's show 'em.
which is sealed. And that's the difference just by those. She interrupts the flow of current, it seems to.
Right.
Anyway.
Positive, negative in the middle. Throw that over.
Can you see that?
Yeah.
Okay.
Put in
Now,
close.
just going in, actually you should be above it.
You want to see the gas, all right.
Okay.
Right away.
Sorry, mate.
Yeah.
I just went to pull away. soon as we touch the negative in, the positive in, we will get gas off our negative.
Oh, okay.
Okay, now we're in solid outside to a solid negative centre. Now you see positive does not put off very much. Negative puts off everything. It splits from negative out towards positive, does not meet with positive both.
Oh, yeah.
See that? So the outside should be a solid.
Mm-hmm.
Negative is your hydrogen.
Now,
Positives are hydrogen, positives are oxygen molecule, negatives are hydrogen.
no, you're virtually
Changes
right.
all the time.
No, you're virtually right, but you get it off both. You get both off both. Positive is not an oxygen. Positive is an oxygen and a hydrogen. Negative is an oxygen and a hydrogen. Okay? And we're going to touch B, aren't we? No. Yes. Can you see that?
Move
See that?
the negative.
Yes. Now, if we come out of the water to our solid, see that?
See how it's not producing as much on the solid?
See the difference? Even though we're really close, look. Right? But then you go to the mesh. See the mesh? And then deeper you go. See? That'll just rip out off the mesh as a negative. Solid spin. You see that better?
Mm-hmm. Yeah, it's better.
Yeah, a lot better. Don't come too close this way, Pete.
No. You don't want it to go, Ben.
Oh, don't worry, man.
What, you deaf, Joe?
Will be soon. And now lift it slowly out, Pete, as she comes past her. We're about there. See the difference?
Yeah, it slows down there.
Yeah. Right. Now,
Woven mesh,
Yeah, put it in.
stainless steel screw.
now this one puts off more larger oxygen bubbles. See the larger oxygen bubbles? Just put it down to the bottom, Pete, I don't care. Just in the middle, same place as the other. Can you see the larger oxygen bubbles now?
How can you tell the oxygen level?
Because you can breathe.
No, but I mean,
Oxygen's a large
See, hydrogen is the smallest, right? It comes off the smallest, and the oxygen seems to be the largest. Oxygen ones do not, well, you can see through them. They're not milky, they're not small, tiny, gassy, or anything else. Right, you see the difference between this gas and the other one? Then we've got twice as much in. You see that?
mm-hmm.
Whatever, we've got twice as much in, up to here, and it doesn't put off nowhere near as much as that small ring.
There's that one.
Oh, it's that one. Understand?
Mm-hmm.
Good. Now we've got something else to put in, Pete.
Well, what about a solid?
Okay, let's try a solid. Don't make it too long so we can see it, all right? Okay, let's see the larger bubbles?
Move it to the side.
Move it to that side.
This way. So the closer you get, she rips out towards the positive. Also positive comes in to meet.
coming off the outside more.
No. That one is roughed up a bit. That one is producing. Right? Try not to get your this in because that's going to produce too, Pete.
It's copper.
Yeah. Okay, so your finer bubbles, right? Hardly any,
And the larger bubbles
Yeah.
on the inside.
yeah. No, the larger bubbles are not doing anything. The inside doesn't do anything. You look in the inside,
So there's only just a few.
the only thing the inside is doing is coming up from the right off the bottom, and then when you lower it deep down, then your jumper leads started producing. See? and then she curled over and went down in the top as he went deeper. Nothing comes out of the middle, it's neutral water.
Shoulder.
We don't use brass or copper or anything. Goes green and pollutes and will completely oxidise up. Completely. That one has only been in for a couple of minutes yesterday afternoon and it has gone green now.
We'll just show, even with a threaded section, right, the size of the bubbles, right, as you move closer to the mesh, how much more rapidly the gas is produced from a threaded section. Okay? See the gas coming away there? The section here, if we try and see the unit on the around the threaded section, you'll see it start to produce, and then you'll notice that it's a lot finer bubble or running off the shinier face. Might have to get it to blow first, Jan.
You can see that, can't you?
You see how it's rapidly coming away from
The thread.
the threaded section, whereas it's not coming away as quickly from
Surface.
the shiny surface.
And this is different too because when you've used plates, doesn't matter how thick the tube is, doesn't matter how polished the sides are or anything else, she goes through, the current goes through, turns both sides into positive and negative and produces on both sides of those plates no matter how thick they are. We showed that other dot with Peter's tube in a minute. It does not have to be in water.
There you are. This is just using another piece of stainless with a yep, surface on it.
Thank you, that many people.
Thanks, Joe. Don't need it.
And just go.
Yeah, they're pop. I threw a match in my bucket. You can't make it go off really.
Oh, you tend to get the bubbles.
Well, if you get enough in a closed space, you would.
I had I got some balloons yesterday. It's coming out the bottom of the gas, where the rough edge is. Very little off surface. The current is going straight down the metal to the bottom and coming out the rough edge. If you rough the plate right up the edges, you would see it coming out the roughest. She breaks away. This mesh is interwoven finer stainless, completely sealed around the threads of the mesh actually, and that doesn't produce a real lot. It comes off the bottom as you see if he pulls her out and then lowers her in. You'll see it coming from the bottom because that's a rough edge where it's been cut.